MJB3 Karl mask aligner system. This system is having a substrate holder, or 2-inch substrate holder. A 2-inch wafer can be mounted on this, and this is the substrate holder table. You can slide in. Before sliding in the table, the chuck up-down lever should be at 3 o'clock position like this, and then it can go in. And then this is the mask holder, and I have a mask. First place the mask holder with the groove visible like that, and then place the mask on the groove with the pattern up, and then we turn on the mask vacuum, and the mask is held under vacuum. So once it is held under vacuum, you have to slide it in the groove here and lock it down. So place the wafer on the substrate holder and slide the table in, and then rotate the substrate up-down lever counterclockwise to 9 o'clock position. And then once the chuck is all the way up, the substrate is touching the bottom side of the mask, the contact light will turn on. At this moment, it is not possible to align the substrate pattern with respect to the pattern on the mask because it is in contact mode. So there is another lever here which has to be slided out like this. The contact light goes out, and when the lever is out, the substrate is lowered by a certain amount of distance of the order of few tenths of microns. Now, viewing through the microscope, we can align the pattern. So once the separation lever is out, we can rotate these knobs to move the substrate. So there's this one moves around y-axis, and this one is for movement in x direction. And there's one more knob here, that is, it will rotate the substrate with respect to the mask. Once the alignment is achieved, push the separation lever all the way to the back till you see the contact light. And here is a timer module. So set the desired time, which can be set in hours to tenths of a second. So you can rotate the knob like that to wherever you want to set it, say 10 seconds or and then, so right now it is 10 times seconds. So the power supply is already turned on, and as soon as I press the expose button, the aligner lamp housing head will move to the aligner tool, and right now the UV rays are on and the exposure is done. So there is a final condensing lens here. I have removed it to show the UV rays here. So currently the power supply is working at 277 watts of power. When the shutter is open, we can also set it in intensity mode, and we can select the intensity levels. So then there is a detector that can be calibrated to read the correct intensity levels. Right now, I have placed an external detector which can detect UV rays at 405 nanometers, and it is measuring about 26 milliwatts per centimeter square. And also on channel 1 here it reads the same amount. There are 3 knobs on the lamp housing. These 2 will move the lamp in X and Y directions, and this knob at the top will move the lamp up and down. So the movement of these knobs is to be done anytime a lamp is replaced in order to optimize or set the lamp at the focus of the ellipsoidal reflector such that the intensity is uniform and to the desired level. And usually a brand new lamp such as this one gives a good amount of power. The lamp ages out very fast, and the logbook should be maintained in order to track the hours of usage of the lamp. I have a second detector. I'm going to quickly remove this detector. And I have a 365 nanometer wavelength detector here, and which measures about 12.2 milliwatts per centimeter square. So there is a set screw in front of the detector. There are 2 detectors, one for 365 nanometer and another one for 405. In order to match the reading on the power supply by adjusting the calibrate button, we can do 2 ways to make the readings match. A, using the calibrate button, potentiometer here, or B is using a 2.2 millimeter Allen wrench. We have to adjust the set screw in front of the detector window by accessing through this opening. There is one more opening on the other side. So the other side detector can be accessed by opening this cap here. The microscope can be focused using the focus knobs on either side here. Also, the intensity of the illumination can be adjusted using the aperture here. Also, there is a knob on the console box here. You can increase or decrease the intensity. And the microscope tower has a manipulator arm. There are 2 buttons on it. Pressing the 2 buttons, we can release the brakes so that the microscope table will move. So this movement is disabled when the buttons are not pressed pneumatically. So after the exposure, rotate the chuck down lever and slide the sample out. Also, there is an additional feature on this system, that is, there is a vacuum chamber button here. By pressing the vacuum chamber button, a vacuum will be generated between the substrate and the bottom side of the mask. So, but during alignment, the vacuum chamber will be disabled. We have to press it again after sliding the separation lever back to its end position. So the mechanism of the vacuum chamber is there is a slot here, and the wafer has to be properly placed in such a way the slot is open and between the gasket and the bottom side of the mask, the vacuum will be generated. So this is a system that can be used either in contact mode or hard contact mode using the vacuum chamber. It's a simple system, and always it is desirable to leave the final lens in this sliding groove. Also, there is a provision here by opening the window here. If only either 365 or 405 nanometer wavelength is desired, then an interference filter like this can be installed in the groove available there. But this is for demonstration purpose. Otherwise, at the exposure area, both the wavelengths are available all the time. There are pneumatic controls here for adjusting the system compressed air pressure, about 4 bar or 60 psi, and this is 30 psi for the chuck parallelity, and this is the pressure underway for 15 psi, and usually we set it about 1 bar, and this one is set usually at 2 bar or 30 psi. So this has to be on all the time, and this is a nitrogen purge needle valve. So this is only to adjust the amount of nitrogen flowing through the system at the chuck between the substrate and the mask in order to release the substrate after the exposure.